Okay, so in example number 3, we want to factor 16y squared minus 6y minus 27. And so just want to point out a little bit, but the variable of the quadratic doesn't always have to be the x. Here I'm using the y as the variable for the quadratic, and so but still, as long as it's a quadratic expression and with leading coefficient, other than 1, and here in this case it's a 16, to factor this quadratic, what works best for me is to draw a square with 4 entries. And once again, what goes in the upper left entry right here? Always the leading term, the first term of your quadratic. And now next what I need to do is I need to multiply 16, which is my leading coefficient, multiplying that to negative 27, which is my ending coefficient, and that would give me negative 432. And now once I found negative 432, the next step would be finding 2 factors of negative 432 that would sum to be negative 6. And so the 2 factors that I can find, the only pair of factors that I can find is negative 24 and positive 18, because once again negative 24 times 18 equals negative 432, and negative 24 plus 18 equals negative 6. And so now with the 2 factors including signs that I have found right here, now I can go ahead and put these 2 factors here anywhere along the diagonal entries right here. And once again, it does not matter which one goes where, so I can simply put negative 24 in the bottom entry and then positive 18 on the upper entry. And don't forget, put in the y in this case, which is the variable of your quadratic. And so now once again, as soon as I've filled out 3 entries on my table, on my square here, then I am ready to find my factors. So now if you look at the 2 entries on the upper row right here, once again focus on the 2 entries of the top row, the upper row. What I'm seeing here is the GCF of these 2 entries would be a 2y. And so so I'm putting the 2y in the outside column right here, and putting that in the same place with the same row with these 2 entries. And then once I found 2y, now think of the other factor. What other factor I need to multiply with 2y gives me 16y squared in this entry? So that other factor has to be 8y. And once again, thinking of this table here as a multiplication table, 2y times 8y equals 16y squared. And then once I found these 2 factors, now right here I would need to, so look at 18y right here. One factor of 18y is 2y. So what's the other factor? It has to be positive 9, because positive 9 times 2y equals 18y. That gives this entry to be 18y. And then if you look over to this entry, now negative 24y has a factor of 8y. And what's the other factor? The other factor has to be minus 3. And so minus 3 times 8y equals negative 24y. And so the answer to the factors of this quadratic is now clear. One factor is 2y minus 3 in parentheses, and the other factors times 8y plus 9 in parentheses. And that is how I factor my third example. The last example for the day. The last example in factoring these quadratic expressions. The last problem would be 6x squared plus 19x plus 15. And once again, here we're still having a quadratic expression. So to factor, what I need to do, once again, I'm going to construct for myself a square with 4 entries. Alright, and always my leading term or my first term of the quadratic, I'm always going to put it in my upper left entry of the square. So here it goes, 6x squared. And now what the next step is to multiply 6, which is my leading coefficient, with 15, which is my ending coefficient, including signs. So it's going to be positive 6 times positive 15, and that equals positive 90. And then at this point, I'm going to need to find 2 factors of 90 that would sum, and once again, 2 factors of 90, including signs, that would sum to be 19. And the 2 factors would be 9 and 10. And once again, think about it. Positive 9 times positive 10 equals 90. And positive 9 plus positive 10 equals positive 19x. So now those are my right pair of factors that I'm looking for. And so now since I found this pair, I can just put them anywhere along the diagonal entries again, and it doesn't matter which one goes where. So here I can put the 9 there, and I can put the 10 here. And don't forget to put in the variable, the x, the variable of the quadratic. And so now at this point, focus on the top row again. Focus on the 2 entries of the upper row. Here, these 2 entries give me a GCF of 3x. And this is where I'm going to put 3x. And once I found 3x, and let's look back into the very first entry right here, the upper left entry of the table. Then the entry here is 6x squared, and 6x squared has 3x as one factor, and so the other factor that contributing into 6x squared has to be 2x, and that's where I'm putting 2x. So because 2x times 3x equals 6x squared. And then looking over to the next entry in the same row, 9x has 3x as one factor, and the other factor has to be positive 3. For the reason being, positive 3 times 3x equals 9x. The last, and if you look into the bottom entry right now, 10x, one factor of 10x is 2x. So the other factor has to be positive 5, because positive 5 times 2x equals 10x. And so now this is the answer to your factors. The quadratic can now be factored into 2x plus 3 in parentheses times 3x plus 5. And this is how you are done with your factoring problem for a quadratic with leading coefficient other than 1.